Hey guys, here I am. I thought we would run through some complex fractions examples. Sorry it took so long to set up. Just getting used to the live streaming thing to make it a little bit easier. I put some examples up over, wrong direction, up over here that we're going to run through. So we'll go through a total of 4. Obviously pause and rewind whenever you need to, and hopefully this will help you, especially if you guys have a 0 and you can't come in. So here we go. Let's start basic. Now remember, with our complex fractions, I apologize for the lighting, we're getting a lot of glare back. So I have 2 over x, all divided by 2/3 minus 2x. There's a piece of tape there. This is why using your kids' stuff from elementary school is always problematic. Anyway, so let's make this a 1x just for grins, because otherwise you could probably just divide those out and make it. This makes it a lot more interesting problem. So what you're going to end up doing is you're going to look for a common denominator. Common denominator, the easiest way to do this is to go through and find the common denominator for all of these. I'll do this 2 different times. The way that I would prefer to do is, okay, common denominator for all the interior fractions would be 3x. And then from there, I'm going to multiply this fraction over here by 3x over 3x. So when I do that, I'm going to, you put it over 1. So everything's going to get multiplied through here and here. The benefits of this, and again, there's some shortcuts we could take here eventually, but again, we're just trying to get you through, hey, let's learn it. So I get 3x over x. And then over here, I'm going to get 6x over 3 minus 3x over x. And again, for those of you just joining, I changed this from the example over here because otherwise you divide it out, you get 1 over 2/3 minus 1, and then what's the fun in that? Now watch, this is going to divide out because the x's go away. 3 is going to divide out, that's going to turn into a 2, and this is going to divide out and give you a 6. Now interesting thing here, you could have done this back here in the beginning because this is missing the 3, so this is going to divide out. 3 times 2 is 6. You don't necessarily have to write this. 3x times 2 over 3. You know the 3's are going to divide out, so it's just going to leave you with 2x, which is what we have here. And then 3x times this, the x's are going to divide out and leave you with a 3. So either way, you're going to end up with 6 as a numerator, and then you're going to get 2x minus 3 as your denominator. And that's it. Ta-da! Done. So pause there if you need to. I'm going to go back and show you a slightly different way you can do that problem. Now the other way that you can do it is this. You're going to try to find a common denominator for this bottom one here. So let's say your common denominator here would be 3x. So I'm going to multiply this by x over x. I'm going to multiply this by 3 over 3. So I would still have 2 over x in my numerator. And then over here, I've got a new fraction, denominator of 3x. Is that coming out okay? Yeah. Not so good. Sorry. So I get 2 over x. I get 3x here. 2x minus 3 would be that, so I get 2x minus 3. And then, since we've got 2 fractions, remember this is really a division bar. So then this will be the same thing as 2 over x times, oh, it's still wet. Sorry. The joys of live internet, right? So anyway, so then we get 2 over x times 3 over x over 2x minus 3. In this case here, the x's are going to go away, and we get 6 over 2x minus 3. Same idea. All right. Let's try the second problem. Second problem, a little bit more involved. Luckily, denominator a little bit easier to mess with because we only have one denominator. So I have 3 over x plus 4 minus a big 2 over 5 plus 2 over x plus 4. So here, this one, since you've got the same common denominator, multiplying everything through by x plus 4 over x plus 4 would really make sense, because when I multiply this here, because again, remember, these are over 1, so you just multiply numerator by numerator, denominator by denominator. So when I multiply these out, the x plus 4s are going to drop. And then I'm going to multiply this here, and I'm just going to get negative 2 times the 4. So over here, 3 times, actually nothing, right? Because that drops. But here, let me show you the work, and then we'll show you the shorthand way. So that'd be your numerator. And in reality, you wouldn't even have to write that down, because that just goes away. And you know that going in because you're multiplying it through by what's in the denominator. In fact, that's the whole reason why we're doing it, to get rid of the internal denominators, as opposed to the eternal denominators, but that's a whole different thing. So this is going to be 3 minus 2 times x plus 4. On the bottom here, I'm going to multiply this out, so that's going to become 5 times x plus 4. Multiply this. This is going to get rid of that, so I'm just going to be left over with 2. Now I hear some of you saying, Mr. Hayes, now we can cancel out the x plus 4s. No, you can't, because it's not a factor, because you got the minus here and the plus here. So you're going to have to multiply this out. Multiply this out, multiply that out, and I'm going to end up with 3 minus 2x minus 8, because the negative comes with the 2. 5x plus 20 plus 2. So when we simplify that, that's going to become negative 2x minus 5 on the top. And then the bottom is 5x plus 22. Neither of these factor, so that would be your final answer. Now again, here you could have combined these into 2 separate fractions. You would get something similar. You would actually come up with 3 minus 2x minus 8 over this x plus 4. Same thing here over the x plus 4. You flip them, x plus 4s drop. Boom, Bob is your uncle, as they say in London. So third example. This one's already all factored out. Y over, let's see what I got, y plus 2 minus y over y minus 2, all divided by y over y plus 2 plus y over y minus 2. Couple of things. Remember, these are not the same. They're not equivalent, so we can't combine them. A second, what is your common denominator for all of this? And that's what I'm going to multiply all this stuff here through by. Now the beautiful thing, and I'll show you the previous step, but before I do that, is that if I multiply all of this through by y plus 2 times y minus 2, multiply, that's fine. Now ask yourself, when I multiply this out, so this whole thing goes to here, and it goes to here, and here to here, etc. What's going to divide out here, and what's going to be left over? The y plus 2s are going to divide out. And so, and again, I'll probably write out the step of this section. When I multiply this through, so it's going to be minus the y, what's going to divide out here? The y minus 2s are going to divide out, which are going to leave just the y plus 2. You're going to do the same thing down here. I'm going to have y, when this comes across, when this whole thing comes into this one, the y plus 2s are going to cancel, divide out. I'm going to end with y minus 2. And the same thing happens here. And again, could there be an easier way to do this? Potentially, because these are so close that you could probably come up with a substitution step if you wanted to. I'm more interested in making sure that you guys get the ins and the outs of what's going on. Now, if you're having a hard time following that, let me write what the step would have been over here. So if I would multiply all of this stuff out, I would have ended up with y times y plus 2, y minus 2, over y plus 2. And let's face it, I know you guys love writing stuff with pencils and stuff, he says sarcastically. But like, for example, that would have been the numerator. These would go away, leaving you with this. These would go away, leaving you with that. Here, the y plus 2's go away, leaving you with this. And the y minus 2's would go away, leaving you with this. If you understand that coming in, I am totally fine with you just skipping from here straight to here. Perfectly fine. Just make sure that you list out this multiplying step so I know what you're multiplying through by, just so that you're not just throwing stuff up against the board to see what fits. Now, this last little step, make sure you got plenty of room here. What in the world? Oh, that's the chair. I was trying to like, what is in the background? So if I multiply this out, I get y squared minus 2y minus y squared minus 2y. Well, that's nice because now these are going to go away. Over y squared minus 2y plus y squared plus 2y. So that's still minus. And that would be minus. What did I think I was thinking ahead too far. So let me just double check this to make sure I didn't get this screwed up. So, actually, it just turns all out to be 1. Yeah, actually, you could have said, wait a second, this is all the same thing over the same thing. Oh, that's because this should be plus here. That's my mistake. Aha! I knew something was wrong. So anyway, so to simplify this out, numerator, these are going to go away. These zero each other out, so I'm going to get negative 4y. Be careful not to say, oh, that's 0, because the signs all match up. Remember, this whole thing goes there. And then over here, these are going to take each other out. I'm going to get 2y squared there. And so the 2 divides into the negative 2, or negative 4, leave negative 2. The y is going to divide out and get rid of this. Y, so you should end up with negative 2 over y. All right, last one. Last one, you get to do a little work with factoring. But by now, you're so comfortable with complex fractions, you must be like, dang, let's go. Make sure it's not wet. All right. So last problem. I think I'll come over here to write it down. So 3 over p squared minus 16. Right now there should be little bells going off in your head saying, wait a second, I know that. Is my audio not even on? Uh-oh. Well, we'll find out, I guess. Sources, audio input capture. Ooh. Sorry, we paused this broadcast, already in progress. Now, can you hear me? We will see. Hey there, boo-boo. Well, there's the audio. All right, well, who knows? Maybe I just screwed everything up. Plus p all over 1 over p minus 4. So again, two options. You could common denominator, put those together, and then flip. It's nowhere near as nice. We already have a p minus 4 here. Minus 4 p plus 4. So that's what we're going to multiply through all of here. This whole thing is going to get multiplied by p minus 4 times p plus 4. And this whole thing is going to get p minus 4, p plus 4. So when this whole thing goes over here, all of this is going to divide out. It's great. You don't have to write anything down. The numerator just comes along for the ride. Plus p minus 4, p plus 4. Now, obviously, oops, and the p goes up there too, sorry. Obviously, this we know is going to be p squared minus 16. And then down here, when this goes through, this will divide out. So I'm just going to get p plus 4. Now, interesting thing here, when you multiply this out, this, remember, is really p squared minus 16. So the numerator now becomes 3 plus p to the third plus 16. It can be minus 16 p all over p to the fourth, p plus 4. So then here I'm going to get p to the third minus 16p plus 3 alone there. And away you go. All right? So I'm going to go ahead and hit stop on this and get it posted up on the internet with a new title. You, my friends, have an enjoyable evening. Stop in and see me in the morning or at lunch if you have the appropriate periods off, and we will talk to you soon.